factor 24x cubed plus 36x squared minus 24x. When we want to factor a polynomial, which is just a sum or difference of a bunch of different monomials, what we can do is we can look at each of these monomials and see if there's a factor that's common to, in this case, all three of them. So why don't we go ahead and just look at the factors of each of these three terms of this polynomial. 24x cubed, we can look at its factors. 24, of course, is 12 times 2, and 12 is 6 times 2, and 6 is 3 times 2. So the factors of 24 are 3 and 2 and 2 and 2, so 2 cubed. Then we also have an x cubed as part of its factors, right? The 36 x squared, we can also look at its factors. Of course, 6 is 6 times 6, and 6 is 3 times 2, and 6 is 3 times 2. So there's two 3's, so 3 squared. There's two 2's, so 2 squared. And then there's also an x squared. And then finally, we can look at this 24x. Well, we already know what the factors of 24 are. We just did that on this previous one. So 24 has factors of 3 and 2 and 2 and 2, so 2 cubed. Then we also have an x as part of its factor. So now we know the factorization of each of those three terms, right? Each of the three monomials that make up the big polynomial. And we can say, what do they got in common? Well, they all have 1, 3. Do they all have more than 1, 3? Well, this one does, but these other two don't. So there is a single 3 that is in each of these. So we know that's part of our common factor. They each have some 2's. This one has 3 2's, this one has 2, this one has 3. Well, they all at least have 2 2's. This one doesn't have enough to say that there was 3 2's in all of them, but we do have 2 2's in each of them, so a 2 squared. Then we also have some x's in each of those terms. And again, we need to look at the one with the fewest number of x's and say, well, okay, this one has x, this one also has x, this one also has x. These ones have more than that, but we only want ones that are common to all of them, and so 1x is the best we can do. So this is going to be the greatest common factor that we'd be able to pull out of this thing, right? So now we have to actually pull it out. If we take a 3 times 4, right, 2 squared is 4, times x out of each of these, what are we left with? Well, if I take 3 times 4, which happens to be 12x, out of 24x cubed, that means I'm getting rid of the 3. I'm going to use up 2 of these 3's, so I'll just have a 2 left. I'm going to use up one of those x's, so I'll have a 2x squared. What about out of the 36x squared? Well, I use up one of the 3's. I use up all of the 2's, and I'm using up one of the x's, so I'm left with a 3x. And then on the 24x, I use up the 3. I use up 2 of the 2's, so I'm left with 1, 2. I use up the x's, so I just have a 2. So, oops, ran out of room. But, so out of the minus 24x, I'm left with a minus 2. So it looks like the factorization of this thing is equal to 12 times x times 2x squared plus 3x minus 2.